Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the different types of DC motors. Kindly refer my before video for explanation of your DC motors. So in this video, we are going to see about the different types of DC motors. Normally, the DC motor works on a principle based on a current carrying conductor which is placed in a magnetic field and a mechanical force is experienced by it. This was the basic outline of your working principle. Then a DC motor is powered at a magnetic field is created in its stator. The field attracts and repels the magnet on the rotor. This causes the rotation of your rotors. Main advantage of using this motor is that it can be immediately started, stopped or reversed as per the essential needs for the control of operation. So this is the types of DC motors. In here, uh, the DC motor is subdivided into a brushed DC motor, then brushless DC motor, and coreless or ironless DC motor. Then this brushed DC is subdivided into a separately excited DC motor, then self-excited DC motor, then permanent magnet DC motors. Then the self-excited DC motor is further subdivided into a series excited DC motor, shunt excited DC motor, then compound excited DC motors. Then this compound excited DC motor is further subdivided into a cumulative compound and differential compound. Then this cumulative compound and differential compound is separated into a long shunt and a short shunt DC motors. These and all the main divisions of your, which means the types of your DC motors. In this video we are going to see about the brushless and coreless DC motors. Brushless DC motor, actually it is a type which is a replicate of your permanent magnet synchronous motor. So it is driven by a DC source instead of AC, and it is accomplished by an electronic controlled commutation system. Normally the commutation which we are seen in earlier videos are like in the basics of your DC motor, the commutation will be taken part in a mechanical wise, but in here brushless DC motor we are using this commutation as a electronically controlled commutation. So the BLDC motor employs a electrical commutation with a permanent magnet rotor and a stator with a sequence of coil. In this motor, permanent magnet or the field poles rotates and the current carrying conductors are in a fixed condition. Then Hall sensors are also been used. The Hall sensor is also known as your rotatory encoders, which is most commonly used to sense the position of your rotor, because the position of the rotor, which is the feedback for your determining of your armature current. Then the armature coil are switched electronically by a transistor or a silicon controlled rectifier or thyristor at a correct rotor position. Then construction wise, this is mainly having a two parts. One is your stator and your rotor. The stator of the BLDC motor is made up of stacked steel laminations to carry out the windings. These windings are placed in a slot which are axially cuts the internal periphery of your stators. Each winding is constructed with a numerous interconnected coils in order to form a even number of poles. Each of the windings is distributed over the stator peripheries in order to spread out the fluxes. Then the permanent magnet is used in a rotor. The number of poles in a rotor can vary up to 2 to 8 with alternate north pole and south pole as per the requirement of the clients or our manufacturers. In order to achieve the maximum torque in the rotor, the flux density of the material should be higher. Then coming up to the types, actually the brushless motor can be layered into two types. One is your outer runner and second one is your inner runner or inner runner. The outer runner, in the sense, the field magnet is a drum rotor which rotates around the stator, which means the stator will be in a inside. This style is preferred for applications that requires a high torque where the RPM will be lower in this outrunner condition. Inrunner in the sense the stator is fixed drum in which the field magnet rotates. This is mostly used for your low torque, but the RPM of this type will be higher. Then next working principle, the stator winding of your BLDC motor are connected to the control circuits. Uh, the control circuit energizes proper winding at a proper time in a pattern which rotates around the stator. The rotor magnet ties to align with the energized electromagnet of your stator, and as soon as it aligns, the next electromagnet is energized. Thus the rotor keeps rotating in this way. The commutator helps in achieving a unidirectional torque in this type of DC motors. Here the commutator and the brushes arrangement is eliminated because we are using a electronical type of commutator, which means a mechanical commutator is eliminated and electronical type of commutator is used. This is the example of your brushless DC motor. In here, as I mentioned, the permanent magnet rotors on the outside and your electronically controlled field coils are at the inside, or the stator coils are at the inside, and the rotary parts, which means your rotary enclaves has been mentioned. This is one of the structure in which the stators at the outside and the permanent magnet rotors at the inside, and your Hall effect sensors which senses the position of your rotor as per the angles requirement will also be shown here. This is your physical structure of your brushless motors. So this is how the structure was mentioned, and the working or the rotations will be takes place as per this alignment. So the Hall effect sensors which is attached with your stator winding ends in order to collect the rotor position and gives the feedback for your armature current. Next is your advantage. It has a no mechanical commutator and associated problems, so wear and tear can be reduced. Then high efficiency due to the use of a permanent magnet rotor up to 80 to 85% of efficiency. Then high speed of operation even in a loaded and unloaded condition due to the absence of brushes that limiting the speed normally. Then smaller motor geometrically and lighter in weight compared with both the induction type and normal brushed AC type. Then higher dynamic response due to the low inertia and carries a winding in the stators. It has a less electromagnetic interference and also quiet operations with a low noise because of the absence of your brushes. Then applications, it is mostly used in your computer aided hard devices, which means hard drives and DVD and CD players. Then electric vehicles, hybrid vehicles and electric bicycles. Then used in your electrical robots, CNC machine tools, and also for belt drive systems, which means like kind of a conveyor belt drives, which normally used in your power plant stations. Then applications in your industrial controls and automotive aviations, then automatic systems like kind of elevators and other automotive systems. Then mainly for your healthcare equipments like which the material equipment which are used in your hospitals. So these and all the main things of your brushless DC motor. Next, coming up to coreless or ironless DC motor. So the name itself you can easily know that there is the absence of your iron cores. Uh, it does not require any iron core in your rotors. It can be a brushed or a brushless DC motor as per the requirement of your manufacturings. The windings of your coreless motors has a typically oblique or a honeycomb design to create a dense self-starting hollow cylinder that is then
held in a place which is used to wear uh, epoxy resins. In a brush or a brushless motor, the stator is composed of a rare earth metal, which means your rare earth magnet, and it is located in the mostly in the internal parts of your motor. Next, construction wise, the stator which sits inside the hollow cylinder is made up of a rare earth metal, which means your rare earth magnet, which is made up of neodymium, aluminum, nickel, cobalt, and samarium, cobalt. Then the brushes in the coreless motor can be made up of a metal like silver, gold, platinum, or a graphite. The housing which guides the magnetic field and act as a magnetic return path for your coreless motor. Then working principle, the permanent magnet fits inside the basket and therefore sits inside the rotor. The air gap which separates the magnet and the housings. The magnet produces the magnetic field. The wire cylinder distributes the magnetic field throughout the structure. When an electrical current is applied to leads connecting to the brushes and the commutators, which interacts with the rare earth magnet to produce a force and rotates the shaft. We will see the general structure now. So this is your coreless or ironless motor looks like. So it has a various parts, in the sense it has a permanent magnet and the housings which is your magnetic field returns, and the shaft which connected with your rotors and the self-starting winding which is surrounding the shafts, and then the commutator and the brushes which is connected with the external load in order to uh, in order to convert the electrical energy into a mechanical energy. Then the supporting bearings and the uh, other small accessories also been used like common DC motors. So this is your overall structures of your coreless or a ironless DC motor. So next we will see one small advantage. So it has a no iron, which means there is no iron loss possible. So and due to this, it has a efficiency of up to 90% than the traditional DC motor. Then motor cocking, which means the issue in the normal traditional motor due to the magnetic interaction of your permanent magnet and the iron laminations. So this is eliminated because we are not using any kind of ions laminations or core. So in this case we will automatically eliminate this motor clogging problem. Next, torque ripple. The torque ripple is extremely low, which provides a very smooth operation and also a minimal vibration and noise in your motor. So next is the efficiency is higher and also compact in a design, which means it can be in a smaller size. Then low drawing current. So when powered up by a battery, the battery will last longer than a normal traditional DC motors. Then coming up to the disadvantages, so it is a significantly more expensive than the normal motor. Then it requires additional electronic parts for triggering. Then it cannot handle a thermal overload as there is no iron cores to act as a heat sinks for your rotor winding. These are all the main disadvantages of your coreless or a ironless motor. The additional electronics, in the sense for the communication purpose we will use some of the electronics types of a thing instead of mechanical commutation. So automatically it will comes into your disadvantages. Next, some of the applications of it. It is mainly used in your healthcare industries like power up dialysis pump, then X-ray machines, surgery tools. Then for robotics, it is mainly used for your positioning of your system and the movement of small wheels or alloys in a project. Then used in your automations and actuator systems. Then in a laboratories, which is used to drive a small but efficient such as a pump, stirrers and centrifugals. Then in office equipment, it is due to their compactable size, it is used in your printers, card readers. Then for a visual audio and visual equipment, it is used in your cameras and audio turnables. So these and all the basics of your motor function, DC motor functions, brushless and coreless DC motors. In coming up video, we will further discuss about the brushed motors. Hope you understand. I think so. Have a nice day. நன்றி, வணக்கம்.